This is a video for 2 TVWO. I'm going to explain exercise T2 of chapter 8. In exercise T2a it says, calculate the area of each of the parallelograms shown below. I've made a sketch of the first parallelogram and the first one is ABCD. I already wrote down area ABCD is base times height. Not divided by 2, that's only with the triangle. With a parallelogram you don't have to do that. Now, I'm going to look for a base and then a corresponding height. A base is always the outside of the parallelogram. So it can either be this one, this side, or this side. Let's have a look at this side first. Is there a 90-degree sign? Yes. So that means that FC is the corresponding height. Do I know what FC is? No, I don't. So I'm not going to use this as a base. Let's have a look at this, because there are also numbers here. If I'm going to take AD as a base, is there a 90-degree sign? Yes. So that means that EC is the corresponding height. I know that one, so I'm going to use AD as a base, which is 10 plus 15. So 10 plus 15 is the base, times the height, which is 20. 10 plus 15 is 25, and 25 times 20 is 500. So the area of parallelogram ABCD is 500. This is the second parallelogram PQRS. I already wrote down area PQRS is base times height. Okay, I'm gonna look for a base now. I have to take an outside of parallelogram, for example SP. I don't know what SP is, but I believe I can calculate it because over here is a right angle triangle and there are two numbers here. So I can calculate this hypotenuse, which is PS. This is the corresponding height when I take PS as a base. UR is not given. I don't know what the length of UR is. And I don't think I can calculate it. So it's not a good idea to take PS as a base. Maybe I can take PQ as a base. That side is given, it's 16, but there's no 90-degree sign here. But this line is extended, so I'm going to follow the dots here. And I can see a 90-degree sign here, which means 32. This is the corresponding height. Again, PQ is the base. That's 16. And the corresponding height is this, 32. 16 times 32 is 512. So the area of parallelogram PQRS is 512. And the last parallelogram is VWXY. I have to calculate the area. I'm going to look for a base. For example, VY can be a base, but I don't see a corresponding height. I don't see a corresponding height either. And over here, I don't see a corresponding height. If I take VW as the base, that can be the base, and then XZ is the corresponding height. That is a possibility, but I don't know what XZ is. I do know that it is in a right angle triangle, so maybe I can figure out what XZ is by doing the Pythagoras theorem. Okay, so I'm going to write down a question mark here. I want to know what this length is, and then I can do base times height. If I look at this triangle, for example, ZWX, this one, I do know this is 20. I want to calculate that one, and I need to know this one. I need to know that one. And then I can do Pythagoras theorem. With a parallelogram, the opposite sides are always the same. So whenever this is 29, then this is also 29. Now in this case, these sides are also 29, but doesn't have anything to do with it, okay? So usually over here you see different numbers. The opposite sides are the same. So this is also 29. Now I can do Pythagoras theorem. So that's side and square. The two sides connected to the 90-degree sign are ZW and XZ. And then the hypotenuse is XW. This one is 20. This one, of course, I don't know. And this one is 29. 20 squared is 400. 29 squared, let me do that on my calculator. 841. And that minus each other is 441. So XZ squared is 441. XZ is 21. Okay, so that side is 21. Now I can fill in that this is 21 and I can use it as the corresponding height. This is the base, which is 9 plus 20 times the corresponding height I just calculated is 21. And 9 plus 20 is 29 times 21 is 609. So the area of parallelogram VWXY is 609. Exercise T2B says, calculate the length of CF and RU. Let's do CF first. So I went back to the first parallelogram, and this is parallelogram ABCD, and it has this length CF in it. And in exercise B, they asked that I have to calculate the length of CF. Now, I can see that this has a 90-degree sign here, which means it is a corresponding height. But to what? What is the base? I see a 90-degree sign is here, so this means that AB is the base. So I'm going to use this formula. Area ABCD is B times height. So area ABCD is, I'm going to take 25 as the base, so AB as the base. Let me write down the letters first. And the height is CF, the corresponding height. Now I'm going to fill in whatever I know. I don't know CF, of course, that's my goal. I want to calculate that. The area I already know because I calculated it in question A. So that's 500, I can fill it in. AB I also know is 25. And then CF I don't know. So now I'm going to do balance method. Do the opposite of times, which is divided by. So I'm going to do divided by 25 on this side, divided by 25 on this side. Just write down whatever I'm doing here. You don't have to do that. Divide this by 25 is 20. So it's 20 is CF, which means that this length is 20. And I also need to calculate the length of RU. So I went back to the second parallelogram, and here it is, RU. I already calculated the area, so I'm going to do the other calculations here. Now, this length is actually a corresponding height because there's a 90-degree sign here. But to what? To this base, SP. So I can use PS as a base and then RU as a corresponding height. And I already know the area. So I'm going to start with writing down the formula. So the area of PQRS is PS as a base and then RU as the corresponding height. So now I'm going to fill it in. I already know the area because I already calculated it's 512. And then PS is the base. I don't know it, but I can calculate it because over here is a right angle triangle and I know this is 32 and this is 24. So I can calculate PS and then I can fill it in. And I don't know RU, of course, but once I know PS, I can calculate RU. So let's do Pythagoras theorem first. Side, square. The two sides that are connected to the 90-degree sign are TP and TS. The hypotenuse is PS. TP is 24, TS is 32, and PS, of course, I don't know. 24 squared is 576, and 32 squared is 1024. Those two numbers plus each other, and that is 1600. So that means that PS squared is 1600. PS is square root 1600, which is, of course, 40. So now you can see it. PS is square root 1600 and PS is 40. So now I know what PS is and I can fit it in here. So 40 times RU. I need to calculate that, and in order to do that I need to do the balance method. I'm going to do divided by 40 on this side. And I'm also divided by 40 on this side. So 512 divided by 40 is 12.8, which means RU is 12.8. So now I'm done with calculating the length of RU. I had to take a lot of steps here. First I had to figure out that PS was the base and then RU was the corresponding height. I wrote it down. Then I was kind of stuck because I didn't know what PS was, but I calculated with Pythagoras theorem. It was 40, and then I filled it in and did balance method to figure out what RU was. So it's actually a lot of steps here, and a lot of students have problems with this because they don't know how to start. I recommend you to start with writing down this sentence. Area PQRS is, and then look for a base and a corresponding height. And just write down the letters, and then you're gonna check what you need to do next. All right, good luck on these exercises, and I hope this video was helpful to you. Thanks for watching.